physics, mechanics, simple harmonic motion. So I won't do the homework. I'll just do these two examples, okay? Right. First example. Okay. You don't need to write this, but I'll draw it for you. So a boy pulls at a spring and releases. The spring begins to vibrate. It takes half a second to complete one oscillation. What is the omega, and how fast is the spring moving after 1 second? So what you have here is you have a boy, and he pulls down on the spring, and the spring is going up and down and up and down, and the time is half a second. Okay, so can you just draw this, please? This is the question, or the information.
What do you mean by the time is half a second?
The time for it to go up and back.
One
oscillation. It doesn't have to be a boy. You can make it a girl if you like. Okay, got that? Yeah. Right, so let's calculate the omega. That's 2 pi over t, which will be 2 pi over 0.5, which is 4 pi. Which is 12.6 radians per second.
Omega is angular velocity.
Okay, what else did I tell you?
How far?
Yeah, I didn't tell you how far he pulls it down, did I? I need to tell you that as well. Or how far she pulls it down. Yeah, you need to know that. So we'll say that the amplitude is something small like 2 centimeters. 2 centimeters. So what's the A here? It is 0.02 meters. Okay, you have the formula. Do we need to use, so you have a choice here. V equals A omega cos omega t, or V equals A omega sine omega t.
Maybe sine omega t.
Yeah, well, if you check your notes, it is
cos.
Cos.
Start at middle or start?
Yeah, it starts at the end here, because she pulls it down and lets go. So it starts, so here it's sine.
Why?
That's what I told you last time.
Start
Starts at
at
the end.
Oh,
so starts at the end is sine?
yeah.
For the velocity.
Which means like if you pull it down and you let go it's sine.
You pull it down, the velocity starts with sine.
Okay, if it's on the top it's cos.
No, still sine. So in the middle it's cos.
Okay.
Okay. Do you know the A? Yes. Do you know the omega? Yes. Do you know the sine? Yes. And what's the t here if it's after 1 second? Well, it's just omega 1, which is omega again. Ah! Now I remember this question. I was being so sneaky. So sneaky. I didn't need to tell you the A. I was being such a sneak here. I forgot. If the time is half a second, it starts at the bottom. Yeah? At rest. After half a second, where is it?
In the middle?
No.
Middle?
No. After half a second, it's back at the bottom. Because the time is half a second. So after half a second, it goes up and down. After half a second again, up and down. And what's its speed?
2.
No, 0. It's back at the start.
Oh.
So I said after 1 second. But the big T is half a second. So it means after 1 second it does this. At rest, up, down, at rest, up, down, at rest. 1 second. It's at rest. The answer is 0. And anyways, if you put that in on the calculator in radians mode, you will get 0. So this was me being sneaky, and I forgot about it.
Like if you ask what is the speed at 0.75.
Yeah, then it would be more.
Then
Yeah,
it would be right.
I number, yeah. I forgot I was being sneaky here. Yeah. Okay, you got this one?
No.
Not yet, okay. Yeah. Yes?
So at the top there is some speed like velocity. 0.
No, it goes here, it goes 0, faster, faster, fastest, slower, slower, 0. And then speeds up, slows down, 0 again. Yeah.
Just like projectile.
Yes. Okay, next one. I forget what piku is. You'll have to check your notebook.
Sensor power magnetic line.
It is definitely not that because that's nano.
Yes, nano.
Oops. Nano, that's what I have to help. It's nano and then pico.
Are you sure?
Yes, I'm very sure. Like
You had just said a moment ago.
because I thought it was nano, but now I know for sure.
So pico is I think 12 or something. Minus 12.
Wow.
Yeah. Okay. Can you at least just write down this sentence, please?
It's center power magnetic storm.
Thank you. Good job, you.
Thank you.
You got it right the second time. Just what I have highlighted.
Just unselected. It's hard to read. Like,
Oh, unhighlight.
yeah.
Yeah. Just this sentence, the first sentence. Here, Grace. Just that. Yes? You sick? Yes. What class did you have at 9 o'clock? Best part of the day. Got the information in the first sentence? No. Alright. I just need the first sentence, you know. Yeah? Can I do it now?
Yes.
Okay. So, what is the frequency here, did I say? What did I say?
8.25 times 10 to the power 14.
Hertz. So this molecule, look. This molecule is vibrating very fast. Very fast, okay? What else do I tell you? I think I tell you the amplitude.
Is 74 pm.
74 piku.
Pico.
Not to be confused with Pikachu.
Pico in Chinese is what?
Pico. Just like I don't know.
Pico. Pico is what, right?
What?
You're saying piku is a bad word in Chinese.
No,
Yeah.
no, no,
Oh.
no,
Have
no.
either piku and ba?
P.
Not the same kind of Pikachu.
I'm thinking Pikachu.
Pikachu.
Yes. Right, so my first question here is what is the omega? So the omega is 2 pi over t. Do we know the t? No. But we know that t is 1 over f. So omega is 2 pi f. So omega 5.19 times 10 to the 15 radians per second. Right, next question is what is the displacement at 1 microsecond? What is the velocity? What's the acceleration? Okay, so I think I'm going to change this second part. So I'm happy with the first part, but I think I'll change the other parts. I'm going to change part 2 now. I'm going to say hang on, let me think. Let me think. I want to use, can I see the formulas? I want to use a different formula. You don't have all the formulas.
I have that show to you.
No, oh, exactly. Okay. So I'm just changing this question a little bit. I'm going to say, what is the velocity when yeah. What is the velocity when
T equals
s equals 10 to the minus 12 meters? So what's happening in this little picture is here's the particle and it's vibrating back and forth. What's the distance here?
10 to the power
No, 74 times 10 to the minus 12 meters. So what I want to know, how fast is it going when it's here? S equals 10 to the minus 12 meters. That might be a little bit too small actually. Let's make it a bit more interesting. Let's just say 4 times that. Did you get a chocolate brownie as well? Nice. Chocolate brownie. Yeah?
Just because looks delicious, so I got it.
That's because it is delicious. Okay, which formula do I need here to get the velocity? Well, it's this formula. V equals no, because we don't know the time. So we need to use what's it? Omega square root a squared minus s squared.
But isn't that to find A?
Oh, sorry. Well,
No.
That's the A.
no, I thought that was for V.
Small A acceleration.
No, the small a acceleration is a equals omega squared s.
No.
No.
Is this wrong?
Yeah.
Are you sure?
A
I wrote it down
equals
as A equals this.
yeah.
A equals plus minus this.
You remember it's wrong. It's A equals, no V.
It's a?
Yeah.
Okay. What is the a? Are you sure?
Yeah.
I don't feel good. Are you sure? I'll double check it because I don't trust myself.
And my experience.
I know I trust my students. I need the formula book. Just check the formula here. Okay, let's see. Looking. Ah, they don't put it in the formula book. Interesting. Interesting. Are you sure? Are you?
That's what we copied at least.
Yeah. Yeah.
But what we copied could be wrong.
No, what I typed could be wrong.
Yeah.
It feels wrong inside my heart. Yeah. So I want to check it before you commit it to memory. I feel like it's B. And why I wrote A? Are you sure I wrote A in my slides?
Yeah.
Well, the fact that both of us wrote the same thing.
Well, yes, that is convincing. Actually, I have the slides right here. I can just check. Ooh, yeah. I don't like the look of that now. Guess we'll find out. Our friend Wikipedia. Okay. Yeah, I was wrong. I knew it. That should be V. Yes. Past Stephen is wrong. Present Stephen is right. It should be V. Okay, we shall fix that. Right, so it is V. Let's calculate it. The red circle? Yeah, what is happening is I want to know how fast the molecule is going when it's at the red circle. So it starts, it's going back and forth, and I want to know how fast it's going when it's a little bit from the center. This distance here, I'll try and draw it again.
It's not near the center, it's 74.
Well, I changed it, I made it bigger, didn't I? So I'll put it here about, yeah? So this distance from the center is this much.
Well, it could be the other side.
Oh, could be, but because I'm getting the speed, I don't care about the positive or negative. Okay, let's type these numbers in. Do we know the omega? We do, that was the last part, wasn't it?
Yeah.
What value did I get? Let me see. 5.19 times 10 to the 15. Square root, the amplitude is 74 times 10 to the minus 12. And the distance is 4 times 10 to the power of minus 12. So I got 383,499 meters per second. Okay.
Yeah.
Lastly, My third part of the question, what do you think I might ask you for now?
B.
No, I have B.
Acceleration.
Yes. So which formula is that?
A equals negative W omega squared m.
Yeah. So do we know the omega? We do.
Do we have this formula?
Oh, you do.
The third formula.
You definitely do.
Yep.
Yes.
Yeah.
Omega squared times the s. Now here, look, if I'm drawing it to the left, then the answer will be positive, and if it was on the right, then the answer will be negative. It's the opposite of this one. So I'll just put it as positive. Now I'm sorry, that's a 40, not a 4. Or is it a 4? I meant 40. I'm sorry. I think I typed in 40. I don't remember. Okay, 40 times 10 to the power of minus 12. So when you put in the omega and the s, I get here, a tiny number. 2.19 times 10 to the minus 31 meters per second squared. Tiny. Oh, no, I made a mistake. It's not that small. That's better. 2.19 times 10 to the 17 meters per second squared.
Why is it to the right?
Because of my picture, because I drew it on the left, the acceleration is going to the right. So here, if it's on the left, the force is going to the right. So this minus here is to tell me that it's in the opposite of this one here. So actually I should have put a minus here, but because it's going to the left. But in the question, I said velocity. Yeah, then I should put a minus here. But if I said speed, then I don't care about the minus. So it's not important. So if you put plus or minus here, it'll give you full marks. It depends if you draw it on the left or if you draw it on the right.
But why
Yep.
why is it that if you want to find the velocity, it's from the right to the left, but acceleration is the left to the right?
Yeah.
Okay, I drew it on the left. It would have been better if I drew it on the right. Better?
But I don't get it. But
What?
the velocity you meant like the ball.
Look.
We can write plus minus, it's fine.
Yeah, look, if you're here, and this is the amplitude, and you're moving to the left, your v is negative, true?
Yeah.
Which way is the force, though? To the left or to the right? To the right. Remember, in the definition, the force is always opposite.
I remember now.
So, what happened was, I made this plus, so I should make this minus, or if I make this minus, I should make this plus. But it depends which side you draw it on. Is it okay now? Is that yes?
Yeah, it's better we can write like plus minus.
Yeah, that's fine.
Yeah. You can sort it out in which direction it is.
Yeah, I'll pick the one.
Yeah. We use 40 here, 40 into.
I should be using 40. I wrote 4, I'm so sorry.
It's
Continue. Let me just change that.
10 pounds, 2.19. Yeah. 170.
The velocity at 40 picometers from the equilibrium. And then I said, what is the value of the acceleration? And now I have to change that formula I showed you last time. That should say V. Okay, homework. Yeah. Only 4 questions. Can you see?
No, I can't see. There's nothing here.
It's blank,
Yeah.
like my mind,
Totally blank.
totally blank.
I can't see anything. Maybe I'm blind.
Maybe. Okay, got this? So we have two lessons to do today, and they're both kind of short. So we have one lesson left in mechanics and one lesson to start in the new chapter. I'll do this homework later in the week, okay?